Welcome to software testing lecture number 4. As I noted before, the goals of my lectures are to give you a general understanding on software testing and also to try to make it quick. Today's subject is going to be structural testing. Okay, we'll start with some definitions. First definition is dead code. Code which will never run for any version of the system. For example, when you started your project, you had a value x which could be greater than 0 or less than 0. But as the project progressed, it was determined that the values of x could only be positive. However, you left the code the same because you figure out it's never going to be negative, but it doesn't harm to leave it the way it is. So that's what you would call a dead code. Next, the activated code. Code which doesn't run for this version of the system. So let me give you an example. For example, if you have an application that comes in two flavors, one is the basic and the other one is the premium. So if you buy the premium, then they would activate certain portions of the program, so you would get more applications opposed to if you buy the basic. And a specified function. Code which isn't needed for the system, but which is there and may have a negative effect. For example, if you have a disgruntled employee, he could add some code which is going to give him access to your program once it gets released and create havoc. You could also have a employee that gets paid by a foreign government to add something to your application so that foreign government can access it. So that's the unspecified function. And then finally we have unverified function. Code which is there and is needed and should have been executed by requirements-based test, but it wasn't. What this means is that you completed your testing program, and when you were done, some of the code wasn't exercised, and probably because your testing program wasn't too good. Okay, so now that we got some definitions out of the way, let me continue with structural test definitions. So, if you look under the hood of your application, what you're going to find is a whole bunch of lines of code, like something that I have here in my chart. Now, for the purposes of structural tests, each line of code, we're going to call it a statement. Basically, what I'm saying is that this is statement 1, 2, so I'm just showing there all the various statements that we have. So overall, we have 9 statements in this routine. Now, statement number 5 is a special statement that we're going to call a decision. The same thing goes for statement number 7. Basically, the outcome of the decision is going to depend in the conditions associated with that decision. So let me pull out this statement, and so this whole statement is a decision, but it's made out of a couple of conditions. So we have condition 1, which is A is true if A greater than 1, it's false if A is less than 1. Then we have condition 2, which is true if B is equal to 0, and false if B is not equal to 0. And then on this decision, we have a third condition, which is made out of the outcome of condition 1 and condition 2. So let's look at the next decision. So this decision is made out of condition, what I call condition 4, which is A equal to 2. then condition 5, which is true if x greater than 1, false otherwise, and then these two are condition 6, which is OR, condition 4 and 5, and the outcome is going to depend, of course, on the value of 4 and 5. So eventually it's going to become clear why am I having all these definitions up front. Okay, so finally we got to structural testing. So I'm going to be dealing with 4 flavors of structural testing. The first one is going to be a statement coverage. Next is going to be decision coverage, followed by condition coverage, and finally something that I've called other coverage. Now, before I go any further, let me put these ideas together. So I show you the first chart where we had all the definition with this dead code and so forth and so on. Well, the way to detect that kind of problems of dead code or non-tested code or spyware is through doing this by doing this kind of coverage: statement coverage, decision coverage, condition coverage, and other coverage. So let's start with statement coverage to see exactly what I mean. Okay. The statement, what it amounts to, the statement coverage is somebody is going to give you a requirement that states each statement shall be executed at least once. Now, you will get this requirement because your software is involved with something that is critical enough that there is some kind of regulation, or somebody in the industry has decided that you better do this. So the first time, so in what I'm saying, the statement coverage requirement, each statement shall be executed at least once. So the way this would work is you would go through your complete software testing program, and then at the end you're going to have to show that you exercise all your statements at least once. Now the benefits is you're going to be able to identify dead code, deactivated code, and specified code, and unverified function. So let me state again. So you run through your whole testing program, and then at the end you come out with a report that's going to show you what portions of the lines of code were not exercised, and you're going to have to figure out if it's a dead code, deactivated code, and specified code, or basically you don't have a very good testing program. You're going to have to readjust your verification and validation program, and then you are going to have to run the test again till you and get a report from your tools to see whether or not you exercise all the lines of code, and if you didn't, then you need some kind of justification. So let's as usually, let's have an example. So here we have a program. I have the requirement at this point is to do statement coverage. So I'm going to have a test case which is going to be n1 equal to 1, n2 equal to 3, and n3 equal to 3 with expected result of 10. Now these n1, n2, and n3 are the 3 values that would come into this subroutine. Now I put all the code I represented in a flowchart to make it easy to follow as we develop as I develop my example. So basically, to meet the requirement of statement coverage, that means that I have to exercise every line of code. So I'm going to have to hit every rectangle here. If I hit every rectangle, that means that I've met the statement coverage. So let's get going. So I have input n1, 1, n2, 3, and n3, 3 as I stated. Then a is equal to n plus 1, so that would give me a equal to 2. Then b is equal to n2 minus 3, so that would be b equal to 0. And then x x is going to be equal to n3 plus 3, so that would give me x equal to 6. So then we get to this decision. So it says a greater than 1. Well, we have a value of 2, so it's true. And b equal to 0. Yes, b equal to 0, so they are both true. So it's yes this way. So then we do b equal to, we compute b equal to b plus 1, which will give us a b equal to 1. And then we continue down. Then we get to second decision, which is a equal to 2. That's true, and this is an OR statement, so it keeps bounces to the next box, which is x equal to x plus 1, which would give me x equal to 7. Then we keep going down, and we return a value of a, which is 2, plus b, which is 1, plus x, which is 7, which is 10, what we expected. So then we get a go for this test. So what I did here is I had a requirement to do a structural statement coverage, and I met the requirement for statement coverage. As you can see, I exercise every line of code. So if somebody had added something that it wasn't supposed to be there, we would have detected, because we would have shown that we did not exercise all the code. So next example. Now, in this case, what I'm going to do is I'm going to show an example where somebody makes a mistake in the code. So what somebody did was, instead of putting an AND on this line of code in this if statement, they actually put an OR by mistake or any other reason. So we can do the same thing on the flowchart. So somebody, maybe purposely or not purposely, modified the code from an AND to an OR. And of course, when you put an OR, it's going to let more things go through these decisions. So we're going to use the same, we still have the same requirement to do a statement coverage. So we're going to do that. So we put in this is the same code as I showed you before. And so we go N133 as before. So a equal to 2, b equal to 0, then x equal to 6, and then we get to the decision. Is a greater than 1? The answer is true. So then I don't have to evaluate the next one, because this is an OR. So then we go to do the b equal b plus 1. So b is going to be equal to 1. We keep going down, and then we get to the second decision, which says, is a equal to 2? Well, the answer is yes. So then we exercise x equal to x plus 1, which gives us a 7. Then we go down, and then our return value is going to be a, which is 2, plus b, which is 1, plus 7, and we get a go. Now I put a go here in red because I wanted to show you that even though we did do a statement coverage, we were not able to detect a major fault, which is a changing an AND for an OR. So the point is that even though because you have a statement coverage, you cannot say, well, I'm going to do statement coverage and forget about the rest. No, sir. You need to still do your equivalence analysis, your boundary, and your guessing, so to make sure that you get data which are going to be able to pick up this stuff. Don't put your blinders and say, hey, I'm doing a statement coverage, so this is good. No, it's not good. It still depends on the quality of your test points. Okay, let's go to decision coverage. Now again, if you get you would get the requirement to do decision coverage, then you would read something like this that you have to do. First, you're going to have to do a statement coverage. That means each statement shall be executed at least once. Next, each decision shall take all possible outcomes at least once. That means that every time we get to the decision, we're going to have to go through the true and false for that decision. And what I'm saying at this point is a stronger criteria than statement coverage, and I'm going to show that it's stronger. And also, if you use something like this, definitely you're going to find a dead code, the activated code again, and specify functions. Definitely you're going to find that, because when the report comes out of your coverage, it's going to show that there is some stuff there that somehow wasn't exercised, and then unverified functions. So now I would like to say that, you know, this structural testing is definitely very expensive. So let's go through our original example. This is the same example as before. The only thing I've done is I've added a test 2, which n1 equal to 2, n2 equal to 4, and n3 to -3. So what I need to do to meet my statement coverage, I need to go down this path, and then as before, I make a right on the true, then come here, and then make another right, and then get down. But that's test case 1. But as I have a statement coverage, then I have to go down, and I have to exercise the no case for this decision and the no for this other decision. So that's why I'm taking 2 test cases. So let's get going. So we have n1, n2, and n3. Now this is same as before, so I'm going to go kind of fast so I don't put you to sleep. So we have b equal to 0, x equal to 6, then we come this way, a greater than 1, that's true, b equal to 0, true, so then we go up here, we have b equal to 1, then we get here a equal to 2, that's true, so we don't have to test the next, it's an OR condition, this is yes, x7, and we get here, we get a 7 plus 1, 8, 10, we get a go, and we have exercised this path. Are we done with our requirement? Are we done with our testing? No, sir, because we have to show for each of the condition the false. So let's get going with our second set of tests. So I selected N2, N4, and N3, -3. Now these values, you have to realize they were selected at the system level. So there was some system level that generated these values. So for A, it's going to be N1, which is 2, plus 1, 3. B is going to be equal to N2, which is 4, minus 3 is going to be 1. Then we go to this statement, which is x equal to n3 plus 3, n3 is minus 3, so it gives me a value of x equal to 0. So then we get to our first decision. Is x greater than 1? No, x is 3. I mean, yes, because a is equal to 3, I'm sorry. And is b equal to 0? That's no, because b equal to 1. So this is an AND, which means that both cases have to be true. So it goes false down. Now we get to the OR condition. Is a equal to 2? The answer is no, because a is equal to 3. Or is x greater than 1? No, x is equal to 0. So then we drop down again. Now you can see that I've exercised the false for the 2 conditions, and then 2 decisions, I'm sorry. And then I have a value, let's see what we return. We return a equal to 3 plus b, which 1, plus x equal to 0, because we did not modify anything. And then, so that would gives us a value of 4, which is what we expected, and we got it go. So in this case, this shows the statement coverage. So what I'm going to do now is go through our all same example, but this time I'm going to change. I'm going to go through the first fault to see if we can detect the error that was committed early on. So if there was if somebody would have changed the AND for an OR. So let's run our test cases. So I'll just run really quick. So this is the first set of numbers, same as before, and in this case we get a return of 7 plus 1, 8. So we get correct value. So we have not so far detected the error. So now let's run the second set of tests. So a equal to 3, then we drop down, then we have v equal to 1 as before, and then x equal to 0. So now when we get to the first decision, we say is a greater than 1, that's true. And as this becomes true, and this is an OR, then we get through, and we end up with b equal to 2. Then we keep going down, and then in this case we had a was not equal to 2 because it's 3, and x was not greater than 1, so we drop this way. So what we ended up here, we say a equal to 3, b equal to 2, and x equal to 0. So that's a no-go. So we expected a value of 4 and we got 5. So using the decision, we were able to detect the problem that we had when somebody made a typo and changed the and for an or somebody wanted to make a change in purpose. Okay. So now that we think everything is safe, let me do something different. So in this case, let's assume that the typo wasn't in this if, but they made a mistake in this other statement, and they changed the or for an and, so they made it more restrictive. So we make it here. And let's go through through the numbers of our two test cases. Test case, I was fairly successful in finding the first error, but if the error was committed at this level in this statement, let's see if we would have detected it. So the first one is same as before. We just keep going down the road, and we should end up with x equal to 10. So which is a go. Of course, I put this in go because I still have one more test to go, but in go in red because we have a major fault here. Okay, so let's run through our second set of tests. Now this is the same test we ran before. So a equal to 3, then we drop down, then we have b equal to 1, and then x, we end up with x equal to 0, and we get to this point. Is a greater than 1? Yes, it's true, a equal to 3. Is b equal to 0? Is b equal to 0? The answer is no, because b is equal to 1. So then we drop this direction. Now we get to the second decision. Is a equal to 2? The answer is no, a is equal to 3. So this is an and, so it just drops down, and then we find out that the return value is going to be a equal to 3, b equal to 1, x equal to 0, which is 4. So what happened in this case is we were not able to detect if somebody had to make a mistake between an or and an and. So again, what I'm trying to tell you is that again we had a decision coverage, which somebody would say, hey, we exercise every line of code, we've tested the true and false for every decision, and guess what? You were not able to detect a major fault, which is changing an or changing an and for an or. So again, my point is that when you select my point is you cannot put on the blinders. When you select your data to be for your testing, you must consider your equivalence classes, your boundaries analysis, in some case knowing the program. So I'm just trying to make sure that I drill into you the fact that statement coverage and decisions, these are really good things to do but they don't guarantee that everything is going to be okay. You still need to be very careful when you select your data. So that comes from the system. From the system level, the data is going to end up meeting all these requirements for statements of R and for decision. Next, let's talk about condition coverage. Okay, if you have the requirement to do condition coverage, then you would have to, what it's going to read like is going to be each statement shall be executed at least once, which is statement coverage, and then each condition in the decision shall take all possible outcomes at least once. And I'll give you an example so you can understand exactly what's the meaning of that. So it's stronger criteria than decision. So I mean, as we go, we're getting to stronger criteria, but again, it's stronger criteria. But that doesn't mean you're going to forget about the rest of the how you're going to select your test cases because I have a stronger criteria. No, that's not the case. So you, of course, you will find dead code, deactivated code, and specified function, and unverified functions. So again, you find some unverified function, then you say, wow, that helped me. So then you add your test cases to make sure that every function gets verified correctly. But still, in top of that, you have to make sure that you can select the correct data that you're going to use for your verification. Okay, so let's go through the example. This time I'm not going to use test cases because you see there would be too many. So I'm just going to give you the idea of what I'm talking about. So let's look at if you have condition coverage for. Let's look at this statement. So what you're going to have to do is show that you're going to have a value for a greater than 1 true and false for this statement, for this condition. I'm sorry. True and false for this condition. You're going to have to do true and false for this other condition, and then you're going to have to make a true and false for the AND. So let's see what this would look like. So I need true and false for this. Then I need a true and false, and then I have to make sure that the combination of these values gives me a true and false for the AND. So basically, if I take a test case that says a greater than 1 and b equal to 0, then I'm going to meet this true requirement for here. Now if I take a value of a less than 1, which makes this false, a less than 1 and b not equal to 0, that's going to give me the fail, which would cover this. So I would have these two test cases will take care of the condition coverage, which means I have true and false for this condition, I have true and false for this condition, I also have true and false for the top. Now the same thing is going to be for a equal to 2. I would have to so I have one test. I would have 1, 2 with 2 test cases. I should be able to cover everything. So the requirements for all the conditions: true, false for this second condition, true, false for this third condition, which is the combination of this. I have true, 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 false, which gives me true and false for this one. So that would meet the requirement. Now what I call other coverage. So there's all kinds of different requirements they can give you and how you're going to do your test coverage. So let's look at what I call other. So in this other, what you're going to be required to do is show all the values, the truth tables. You will have true, true, false, 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 true, true, false. So you would have to exercise. You would need you would have to come out with a greater than 1 with a true, false, and also with 2 false statements. So you would have to have a you have to make, I'm sorry, for a greater than 1 and b equal to 0, you're going to have to come out with the truth table, basically. That's what it amounts to. And the same thing is going to be for this. So this would require 4 and 8 test cases. So that's what I have for today on structural testing. I hope I've given you the flavor of structural testing. So let me, before I wrap everything up, I just want to give you, for you to understand that you run your regular verification program, and then if you have a requirement to do a statement coverage, then you have to, at the end of your program, you're going to have to somehow show that you met that requirement. And usually that would take for you to instrument your code in such a way that you know that everything has been exercised and to what level, and there are tools that do that kind of stuff. So let me recap the whole thing. So I gave you the definition of what a statement is, which is a line of code, then the definition of decisions, and the definition of conditions. I also talked about dead code, which is code that's never going to be exercised. Somehow it did not get removed from the program. Somebody figured out that it wasn't going to do any harm. I would like to say that I've heard about a code that folks run through their program, and somebody decided, hey, this is dead code, and the requirement was not to have any dead code, so they removed it, and they actually broke their application. So what they thought it was a dead code, it turned out to be just that their verification program was no good. So that's why that code did not get exercised. It was not dead code. So we have the activated code. That's a code that gets another example would be if you go from one type of hardware to another, you may want to just deactivate some of the code that is not there. You don't need it anymore. And specify function, we talked about, you have somebody add something special to your program that is going to hurt you on the long run, or wants to spy on your program, or wants your program to do something else later on. So very dangerous, this unspecified code. And unverified function, that's when you run your program, you did not somehow certain code did not get exercised, and it turned out to be that it wasn't dead code, it wasn't deactivated code, it wasn't specified, it was just that you had a bad, not a good tested program. Then I talked about statement coverage, which means you're going to run you're going to report at the end of your verification program that you've exercised every line of code in your program. Then I talk about decision coverage, which means that you're going to go and you're going to verify that the decision that each decision, the true and false, got exercised. And then talked about conditions, in which you actually look at the conditions and make sure that each condition was run on the true and false results. And then finally I talked about other coverage, which means this is type of coverage that somebody can decide is required for a particular industry, and they have to do with to what extent you exercise the true and false tables associated with the conditions. So anyhow, I hope that's what I had for today. I hope you've enjoyed the lecture. And next week, or next lecture, I should say, not sure it's next week. Next lecture, we're going to be dealing with problem reports, which is kind of important because that's how you get your scoreboard. What's your progress based on how the problem reports how problems get reported, how problems get solved and retested. So anyhow, you can also find these lectures in YouTube if you need them a little larger format, and subscribe so you'll get a notification when I come to my next lecture. So anyhow, thank you very much, and happy testing. Bye bye.